Welcome back. In this video we shall talk about 2D discrete cosine transform or two-dimensional discrete cosine transform. Let's say we have an input matrix I where I of 0 0 represents the element of matrix I at first row and first column. I of 0 1 represents the element at first row and second column. So why we started representing the elements from 0 0 and why not from 1 1? We will talk in the next slide why we started from 0 0. 2D discrete cosine transform is defined by the formula T of AB and this whole formula, where T is the transformed matrix, XY denotes the row number and column number of I is the input matrix, and AB denotes the row number -1 and column number -1 of T. Why we are using row number -1? Because the counting is started from 0 0. The counting of the elements is started from 0 0. So in this case, when we use XY, so the first element at first row and first column will be I of 0 0, and so the column number is 1 and the row number is 1, but here it comes 0 comma 0. So 1 minus 1 is the row number, so we minus 1, we take minus, we subtract 1 from the row number, so it will become 1 minus 1 is equal to 0, and column number is also 1, so we will subtract from 1 from 1, which will be 0. The last element of this matrix I will be I of 2 comma 2. This will be the element at third row and third column, so the row number will be 3 and the column number will be 3. We subtract 1 from the row number to obtain the value of x, and subtract 1 from the column number to obtain the value of y. Similarly, this is done from in the same way this is done from for T of AB. For example, when T of AB is equal to T of 1 comma 2, so it will represent the element at location second row and third column. So it will be the element at second row and third column. So we subtract 1 from the row number, it will become 2 minus 1 is equal to 1, and 1 from the column number, so it will become 3 minus 1 is equal to 2. So x is the number of rows in I and y is the number of columns in I. So the loop will go, the summation will go from x is equal to 0 to x minus 1, where x is the number of rows of I and y is the number of columns of I, and the summation goes from y is equal to 0 to y minus 1. So in this case the number of rows is 3 and the number of columns is 3, so the summation will go from x is equal to 0 to 2 and y is equal to 0 to 2. K of n is defined by this equation which is used here. K of a will be under root 2 over 2 when the value of a is 0, or K of 0 will be 2 under root square root of 2 divided by 2 when the value of a is equal to 0. K of a will be under root 2 over 2 when the value of b is 0. K of b will be under root 2 over 2. So either the value of a is 0 or the value of b is 0, the value of constant k of n or k of a or k of b will be under root 2 divided by 2. In other cases, when the value of a and b is not 0, for example, if the value of a is 1, k of 1 will be 1. If the value of b is 1, so k of 1 will be 1. Similarly, if k is equal to a is equal to 2 or b is equal to 2, so k of n will be equal to 1. So this is our transformed image. So we will obtain t of ab using this equation. First of all, we will put 0 here and 0 here, so t of 0 will be obtained and will be placed at this location. Next, we increment the value of increment the value of b and keep it 0, so t of 0 1 will be here. Similarly, all the elements of this matrix T will be obtained using this equation. So let's see in detail what is happening inside the discrete cosine transform. This is the formula of this discrete cosine transform. We can call this value a constant. This is the constant value, and these are the summations will be placed as it is, and this is used to calculate the b, which is the basis function. So let's say we have to calculate t of 1 comma 2, so the basis matrix of 1 comma 2 will be calculated using this equation. So we will calculate a whole matrix using this equation. First of all, we will place the value of x is equal to 0 and y is equal to 0 and calculate this value. Note that the value of a and b are constant, which is equal to 1 comma 2. The value of a is 1 and the value of b is 2. So this whole matrix will be the basis matrix for b of 1 comma 2. So it will be a 3 cross 3 matrix. Similarly, when then we place x is equal to 1 and y is equal to 0 and obtain this value. Then we place x is equal to 2 and y is equal to 0 and we obtain this value. Similarly, by putting all the values of x and y in this equation, we obtain the basis matrix. Then the basis matrix will be multiplied element wise. This is the element wise multiplication. So the matrix b of 1 comma 2 or the basis matrix of 1 comma 2 will be multiplied with the input matrix I, and this will be the element wise multiplication. So after the element wise multiplication of b of 1 comma 2 and I, we will obtain y of 1 comma 2. Then after this we will sum all the values of this matrix. All the values will be summed up and multiplied with the constant, and we will obtain the value of t of 1 comma 2. Okay, we can calculate the t of 1 comma 2 using the basis method in which we take the dot product, or by directly putting the values in this equation we can obtain the value of t bracket 1 comma 2 or t of 1 comma 2. So it can either be calculated using the basis method or by directly putting the values of x and y in this equation. So why we use the basis method? Because to let us understand the process, understand what is happening inside the DCT. So this is the basis matrix for 8 cross 8 matrix. This is the basis, these are the different bases. For example, this will be the basis for 0 comma 0, basis function for 0 comma 0, and it will be an 8 cross 8 matrix because the size of the input matrix is 8 cross 8. In our case, the size of the input matrix is 3 cross 3, so all the basis matrices will be 3 cross 3. So we calculated in the previous slide basis matrix for 1 comma 2. Similarly, we can calculate for basis matrix for 0 comma 0. It will be a 3 cross 3 matrix. Similarly, we can calculate basis matrix for 0 comma 1, basis matrix for 0 comma 2. These all will be 3 cross 3 matrices. So we will obtain 9 3 cross 3 matrices. So each basis matrix will be multiplied with the input matrix, and it will, the values of the resultant multiplication or element wise multiplication will be summed up, and the transformation at the respective location will be calculated. So we calculated t of 1 comma 2, and this t of 1 comma 2 will be placed at this location. Similarly, t of 0 comma 0 is calculated and will be placed at this location. In this way we will obtain this T matrix, and it will be a transformed matrix. So this image shows the basis matrix, basis for 8 cross 8 input matrix. So this will be the cosine. These will be different frequencies of cosine. So in B of 0 comma 0, the frequency is constant, so there is only one shade. In this B of 0 comma 1, there is a horizontal change in frequency. So in this case there is more change in horizontal direction, and more change in horizontal direction in this case, and more change in this case. Similarly, here will be the change in vertical direction, and more change will be in this basis, and more change will be in this basis. So we will obtain 8 cross 8 basis for 8 cross 8 input image, and each basis will be 8 cross 8 matrix. So in our case we will obtain 3 cross 3 or 9 basis matrices, and each basis matrix will be 3 cross 3. So let us perform this in MATLAB. Let's open the MATLAB. I have already calculated these things for you. For example, this is I, the input matrix. We defined an input matrix I, and then we calculate the size of I will be placed at x, which the number of rows will be x and number of columns will be y. We define the variable a and b. So we will calculate t of a comma b. So first of all we can calculate for t of 0 comma 0. So these are the constants. If a is equal to b 0 and b is equal to 0, the value of ka will be square root of 2 divided by 2, and kb will be square root of 2 divided by 2 if the values of a is 0 and the value of b is 0. Else if the value of only a is 0, k of a will be square root of 2 under divided by 2, and the value of kb is 1. So this is the implementation of this is the implementation of this formula. So we calculate the value of constant in this way. Similarly, if the value of b is 0, the k will be 1 and kb will be square root of 2 divided by 2. Else ka is equal to 1 and kb is equal to 1 when neither a is 0 nor b is 0. So constant will be constant. This is this constant. So we calculate the value of this constant, which will be equal to 2ka into kb divided by under root xy. So the value of constant is calculated. So b is initialized and b is an matrix containing zeros. So b will be the basis matrix. So we will calculate the basis matrix in this way. So then we multiply, do element wise multiplication of input matrix I and the basis matrix b. Then we sum all the values of y and obtain obtained a number z. Then z will be multiplied with the constant to calculate the tab, or this tab will be calculated. tab will be calculated. In this case, the tab will be t0 comma 0 because the value of a and b is 0. So we run this program. So we will check the value of b. So it will be a constant. So let's change the value of a is equal to 1 and rerun this program. So now we see the value of b. So it will be a change in vertical direction. So there is a change in vertical direction. You can see the sign changes from plus to minus. So there is a change in vertical direction. If we keep b is equal to 1 and keep a is equal to 0 and we run the program, there will be a change in horizontal direction. You see there is a change in horizontal direction. In the next we calculate the transformed matrix using the direct method. We will calculate the value of constant in the same way. Then the transformed matrix T will be initialized. It is initialized here, and A is equal to, A goes from A to x minus 1, B goes from 0 to y minus 1, and all in the same way all the elements of T bracket A comma B are calculated. Why we used A plus 1 and B plus 1? Because in MATLAB the elements start from 1 comma 1, or the first row in MATLAB is 1 and the first number of columns in MATLAB is 1, because the index values in MATLAB, index values of a matrix in MATLAB start from 1 comma 1, and if we don't use A plus B and B plus B, it will start from 0 comma 0 and will give an error. So this will be when A of A is 0 and B is 0, this will be T of 1 comma 1, which will be the value of T of 0 comma 0, because first element in DCT is 0 comma 0. So we will calculate the whole matrix in this way. Next we see the value of t. So this is the value of we did not run the, let's run this program, and we see the value of t. So this t will be the transformed matrix. So that's all about DCT. Thanks for very patient listening, and we will see you in the next video.